All right, we're on 7.04 today for pre-calc, and we're going to start talking about matrices. So matrices offer a streamlined technique for solving a system of linear equations. So it's just kind of a different way that we can solve a system, especially when you have more than two variables. A matrix is an m by n rectangular array where m is the number of rows and n is the number of columns. For example here, so these A's are all elements of your matrix. So here you have A sub 1, 1, meaning it's in row 1, column 1. A1, 2, it's in row 1, column 2. And then you could continue until you get to the nth term. So this one is still in row 1, but in column n this time. And it goes down like that. So now this one is in the second row, first column, second row, second column, and then the second row, the nth column. You go all the way down to the bottom where you'd have the mth row in the nth column. So you can have a matrix as big as you would like. And we'll talk about how to solve those as well. But today we're mainly doing some basic stuff, and we'll end with a basic system with two variables. So first of all, let's talk about the order of each matrix. So pretty much order is asking you to find the size of it. So when you do the size, it's always rows by columns. I always remember RBC, rows by columns. R for rows, B for by, C for column. So if you want to say rows by columns, you first look at the matrix. So in letter A, we have just one element in our matrix, and that's a 2. So if I want to say the order of it, it has one row and it has one column. So it's a 1 by 1 matrix. All right, let's look at B. So B, we have 1, 2, 3 rows. So remember, row is across. So we have 3 by how many columns? We have 1, 2 different columns. So the order would be 3 by 2. Think of a column like when you see on a house or a building, when you have a column goes up and down, that's your column. For letter C here, we have one row and we have 1, 2, 3, 4 different columns. So this would be a 1 by 4 matrix. All right, pause the video here and find the order of letters D and E. So here you should have had 2 rows by 3 columns, so that's a 2 by 3 matrix. And lastly, this one would be a 2 by 2, 2 rows by 2 columns. Next, let's talk about just writing it as a matrix. So if this is our system right here, you've seen these before, a system with 3 variables in it. We want to write an augmented matrix for this. So what that means is you're going to take the coefficient of each variable and you're going to write it without the variable in front of it. So the coefficient of x is a 1. The coefficient of y is a -4, and the coefficient of z is a 3. And then sometimes you don't see this line, but it really helps us to organize it sometimes. So I like to draw the line, and then after the line, kind of like your equal sign, I put the 5. So now you're going to do the same thing for the next row. So now I just take the coefficient. So -1, -3, -1, and then -3. Pause the video here and write out your coefficients for the last row. So here you should have 2. There's no y value, so the coefficient is a 0, -4, and 6. And we usually close them up with square brackets. So that's your matrix for that system of equations. Now, when we have a matrix, we're able to do some elementary row operations. So these are the things that you are allowed to do. You can interchange two rows, so you can switch the rows around. You can multiply a row by a non-zero constant. So as long as it's not zero, you can multiply a row by anything. Just like with a system of equations, you can multiply an equation by any number you'd like. And this one is the one we're going to use the most, is add a multiple of a row to another. So let's take a look at what those look like. So number 3 says create a row equivalent matrix by performing the indicated operation. Label the row with the operation performed. So letter A says interchange the first and the second row. And so when you label it, and this is something that is important to me that you show, is I want you to write what you did, and I like you to label it on the new matrix. So here, I'm going to switch row 1 and row 2. Okay, so this is going to go up here, and the pink row is going to go down there. So my first row now will be -1, 2, 0, 3. My second row will be 0, 1, 3, 4. And the last row will stay the same here. To label that, you're going to draw a little arrow to show that you switched them. And you're going to write row 2 and row 1. So row 2 went to the top, row 1 went to the second line. So you're allowed to do that with any rows in your matrix. You can just switch them up. Letter B, multiply the first row of the original matrix by 1/2. So again, when you're doing it, I want you to label it on the new matrix. So 1/2 times row 1. So now I'm going to take everything here and multiply it through by 1/2. So 1/2 times 2 gives me 1. -4 divided by 2 is -2, or 1/2 times -4. 1/2 times 6 is 3, and 1/2 times -2 is -1. Everything else stays exactly the same. So you're just rewriting all of that in your new matrix. And again, labeling it on the new matrix that you write. And then the last thing that we can do here is add a multiple of a row to another. So we're going to add -2 times the first row, and we're going to add that to the third row. So -2 times the first row added to the third row. So whatever row you're adding it to, that's the one that you're going to change. So in our new matrix, to label what we're doing, we're going to take -2 times row 1 and add it to row 3. Now with these matrices and their operations, a lot of times I like to use my fingers to guide me through each operation that I'm doing. So I'm doing -2 times the first row. So I would do -2 times 1 is -2, plus 2 gives me a 0. And actually what I'll do before I do the rest of that is I'm going to just write in the rest, because none of this is going to change. The only row that's changing is row 3. Okay, so now let's go back and do the second term. So we're looking at row 2, column 2, or sorry, row 3, column 2. So now we're looking at, we're going to change this 1. So to change it, we're going to do -2 times row 1, -2 times row 1, so -2 times 2, plus 1. So -2 times 2 is -4, plus 1 is -3. Next, we're going to do the -4. So -4 times -2 is 8, plus 5 gives me 13. And then -2 times 3 is -6, minus 2 is -8. Now, I know that is a lot to do in your head, and a lot of mistakes can be made. So if you'd like to, off to the side, show that work, you're welcome to do that as well. But these are ones that you don't have to show work on. You can just write in the row at the bottom, which is kind of both the benefit and the drawback of these, because it's easy to make a mistake on them. So be very, very careful as you go through them. So those are your three things you can do to the matrix. So switch two rows, B, which is multiply a row by any number you want, and C, add a multiple of one row to another row. And again, it changes the row that you are adding it to. And I want you to always label on the new matrix. All right, now we're going to talk about a lot of vocab here with row echelon form and reduced row echelon form. So row echelon form means any rows consisting of zeros must occur at the bottom of your matrix. For each row not consisting entirely of zeros, the first non-zero entry is going to be 1. We call that your leading one, your lead one. For two successive non-zero rows, the leading one in the higher row is further to the left than the leading one in the lower row. So we call that like a staircase. So it would look something like this. So if you had 1, 0, 3, then our next row would be 0. So the first non-zero entry would be a 1, be a 2, and 0, 0, 1. So see how you make a staircase with your ones. So that in each of these ones should have zeros below it. A matrix that is in reduced row echelon form, if it is already in row echelon form and every column that has a leading one has zeros in every position, both above and below its leading one. So here in reduced row echelon form, so this is just row echelon form. In reduced row echelon form, you would have 1, 0, 0. I'll do it like how we'll see it. 2, 0, 1, 0, 3, and 0, 0, 1, 4. So every lead one that you have must have zeros above and below it. The only other numbers besides 0 and 1 should be over here on the other side of the equal sign. So what this is actually telling you is 1x plus 0y plus 0z equals 2, which means x equals 2. Here, y equals 3, and here z equals 4. And then we have a name for each of these. So in row echelon form, that's where we use Gaussian elimination. So it's the process of converting to row echelon form. So that's when you have zeros just below your lead ones. You don't have to have them above and below. And let me also add in here for reduced row echelon form, that one we call, the process is Gauss-Jordan elimination. And we're going to really focus mostly on Gauss-Jordan, getting the zeros above and below. All right, number 4, determine whether each matrix is in row echelon form. If it is, determine whether the matrix is in reduced row echelon form. And if it's not, state why. Let's look at the first one together to see exactly what I'm asking you for here. So I want to know, is this in row echelon form? So you're looking for if I have any rows of zeros, those have to be at the bottom. I don't have any rows of zeros here. We have to make sure that your ones are that staircase of ones, which we appear to have. Then we also want to decide, is it reduced row echelon form? So for reduced row echelon form, that's when you have to have zeros above and below the numbers. So you'll see this one right here. There's a 2 above it, so that makes it not in reduced row echelon form. Same thing with this one. There's a -1 above it, so it's not in reduced row echelon form. So this is row echelon form. You've got your leading ones in the front of each row, but it's not in reduced row echelon form. And that's because the leading ones in row 2 and 3 don't have all zeros above them. Okay. So pause your video here and decide if letter B is in row echelon form, and then decide if it's in reduced row echelon form. So here, because this row of zeros is in the middle, it's not at the bottom, it's not in row echelon form, and it's not in reduced row echelon form. So no, because the row of zeros is not at the bottom. Okay, try letter C and D. Pause your video and tell me if letter C and D are in row echelon form and if they're in reduced row echelon form. All right, so here, when we look at letter C, you'll see this 2 right here is the first non-zero entry in row 2. So it's the first number in the row that's not a 0. And when that happens, the first number must be a 1. So see, it's a 1 here and it's a 1 here. But in the second row, it's not a 1. So that means it is not in row echelon form. So that's because row 2 doesn't have a lead 1. And letter D, our row of zeros is at the bottom. And each of our first entries is a 1 after all the zeros in front of it. So this one is in row echelon form. So now the question is it in reduced row echelon form? So that's where we want to look at all of our leading ones and make sure there's zeros above and below. So here is our lead 1, there's zeros below. Here's another lead 1, a 0 above and below. And this last column doesn't matter that there's a 3 and a 5 here because we don't have another lead 1. So this could be saying just that we found your Y and your Z there. So this is in reduced row echelon form because there are zeros above and below all your lead ones. So again, whether this line is there or not, we know that that's in row echelon and reduced row echelon form because this row of zeros just doesn't tell us anything, but it does have to be located at the bottom. All right, next, let's actually use it. So use matrices to solve the system of equations. Let's use Gaussian elimination. We say that it's Gaussian with back substitution. So I'll show you what I mean by that. When we do these, the first step is you're going to get a lead 1. Then you're going to get zeros below that. And then for 3, you're going to repeat for the next row. And you're really going to work by columns here, looking to get those lead 1s in each column that you see. So that is for Gaussian elimination, which is in just row echelon form. So we don't have to get zeros above and below. That's why we're going to use back substitution at the end. So first, let's write our matrix out. So we have 3x plus 2y equals 7. So we take the coefficients of that in our augmented matrix. So 3, 2, and then I'm going to draw a line for my equal sign and a 7. And then the second equation is 2x. So I take the 2, the 5, and the 1. So this is the original problem. All right, so first we want to make sure that we get this 3 to become a 1. So how do we get a 3 to become a 1? Well, we're going to multiply it by 1/3. So never think of it as division. Always think of it as multiplication. Let me scroll down a little bit. All right, so first we get our lead 1. So I'm going to multiply 1/3 times row 1. So to do that, I'm going to take 3 times 1/3, which is 1. 2 times 1/3 is 2/3, and 7 times 1/3 is 7/3. Second row stays the same. So now I have my lead 1. My next goal here is to get a 0 below it. So I want this 2 to become a 0. Well, how do I get that to become a 0? So to get the ones, to get the lead 1s, you're always going to just multiply by the reciprocal. To get the zeros, you're going to multiply whatever row you got the 1 in, the lead 1, multiply that by the additive inverse of this number, and then add it to that row. So once we get our 1, we'd say, well, what do we need to add to 2 to get a 0? We need to add a -2. So how can I get a 1 to become a -2? Well, I'd do -2 times 1 plus 2 would give me a 0. So that means I'm doing -2 times row 1, and I'm going to add that to row 2. So row 1 will stay the same. For row 2, I'm going to do, and here's where I like to use my fingers a lot. So I'll like line up my fingers just to keep my eyes focused on what I'm doing. So I would do -2 times 1 is -2 plus 2 is 0. Again, if you need to write the work off to the side, that's 100% okay. Here we have -2 times 2/3. So that gives me -4/3 plus 5. So if you need to do that off to the side, you can. Or at this point, if you want to use your calculator, you can. So -4/3 plus 5. So I want a common denominator of 3. So -4/3 plus 15 over 3 would give me 15 minus 4 is 11 over 3. So this would give me 11 over 3. And then I'm going to do -2 times 7/3. So notice I'm always going back to the matrix before this one. So -2 times 7/3 is -14 over 3 plus 1. So again, if you want to do that off to the side, -14, maybe make work. -14 over 3 plus 1, or that's plus 3 over 3. And that's going to give me -11 over 3. And of course, check those in your calculator. So now I finished my first column. So you always want to focus on your first column. So now I have a lead 1 with a 0 below it. Now I need to look at column 2. So for column 2, I need to get this 11 over 3 to become a 1. So anytime you want to get a number to become a 1, you multiply it by the reciprocal. So let me just make a note there. To get a lead 1, multiply by the reciprocal. To get a 0, you're going to multiply, you're going to add a multiple of one row to the other. I don't want to get too confusing in that, in this part right here. So just add a multiple of a row to that row. And the row that you should be multiplying by should always be the row with your lead 1. Add multiple of the row with your lead 1 to that row. Okay, so now we want to get 11/3 to become a 1, so we're going to multiply by the reciprocal of 11/3, which is 3 over 11 times row 2. So now I have 0 times 3 over 11 is 0. 3 over 11 times 11 over 3 is 1. And 3 over 11 times negative 11 over 3 is negative 1. Now, it's really, really important that you do everything that, and I'm going to rewrite this, all the steps that I've said must be in the same order that I did them in. That is extremely important. These don't work if you don't do them in the right order. So you have to get the lead one first for your column, then you have to get the zeros below it. If you go astray from this system and from this order, what will happen is you'll get that 0, but then when you try to get your lead 1, if you try to add something to get to that, then you're going to lose the 0 that you just worked to get. So really important, you're always getting your lead 1, then zeros below. Lead 1, then zeros. All right, and then since we're doing Gaussian with back substitution, once we get all our lead 1s, now we can actually put it back into our equation. So 1x plus 2/3 y equals 7/3. And the other equation is y, so it's 0x, which is just 0, and y equals negative 1. So now I can take my y equals negative 1 and substitute it back into the other equation. So I'd have x plus 2/3 times negative 1 equals 7/3. So that's x minus 2/3 equals 7/3. Add 2/3 to both sides, and we get 9/3 or 3. So our answer would be x is 3, y is negative 1 is the solution to that problem. Okay. So that, again, is using Gaussian elimination with back substitution. This part right here that I did with the equations, once I put x and y back in, that's back substitution because you're substituting this back into the other equation. Now we're going to do it using Gauss-Jordan elimination, which means we want to put it into reduced row echelon form. And this is the way that we're going to focus most of ours on. So it's a little bit more using matrices instead of the back substitution. So same beginning steps. So first we're going to rewrite it as our augmented matrix. So 5, 3, 9, 2, negative 4, 14. That's our original matrix. Now, again, we want to get your lead 1 in column 1, then 2, get zeros below. Then get your lead 1 in column 2, and then 4, get zeros above and below. So it's really important to always be following these steps. All right, so we've only got 2 variables here. So first thing we'll do is we're going to get this 5 to become a 1. To get a 1, you're going to multiply by the reciprocal. So we're going to multiply row 1 by 1/5. So everything gets multiplied. Actually, you know what? Instead of that, I see this second row here is all divisible by 2, and the first number is a 2. So that actually could eliminate some of our fractions. So we might want to switch those rows first. So let's try it that way. Okay, so first let's switch them. So we're going to do 2, negative 4, 14, 5, 3, 9. Again, you're always allowed to switch your rows. So this one is row 2 and row 1. All right, so now we'll get this to be our lead 1. So that's, we want to try to avoid fractions, which is why I switched them. So I noticed this, if I divided everything by 2, I wouldn't have any fractions. So now I'm going to do 1/2 times row 1. Remember, we're always multiplying, not dividing. So 2 times 1/2 is 1. 1/2 times negative 4 is negative 2, and 1/2 times 14 is 7. Second row stays the same. So now we have our lead 1, we need to finish the column by getting zeros below that. I'm going to come up here. All right, so to get a 0, you're going to multiply the row with the lead 1, so whatever's circled, by the additive inverse of 5. So multiply this one by -5 and then add it to row 2. So here we're going to have -5 times row 1 plus row 2. So first row stays the same. Pause your video here and try and figure out what your new row will be. All right, so -5 times 1 plus 5 is 0. -5 times -2 is 10 plus 3 gives us 13. And -5 times 7 would give us -35 plus 9 would give us -26. Now I finished my first column. So I have a lead 1 with zeros below it. Now I need to get my next lead 1 right here. So I need that 13 to become a lead 1. So how do I get that to become a lead 1? Anytime you're doing a lead 1, you're going to multiply by the reciprocal. So I'm going to do 1 over 13 times row 2. 1 over 13 times 0 is just 0. So all the work we just did to get that 0, we keep because we're just multiplying it by something. That's why you can't add rows together to get rid of, to make anything a 1, because you'll mess up everything you did before. So we 113 times 0 is 0, 1, and then -26 times 113 is -2. So here's where you'd stop if you were doing just Gaussian elimination with back substitution. But we want to continue and to do Gauss-Jordan, so get zeros above and below. So now I need this to become a 0. So whenever you're getting zeros, you're going to multiply the row with your lead 1. So this row is below it in this case. So we're going to multiply 1 by, actually pause your video and try and do this on your own first and then check back. All right, so you should multiply this 1 by 2. So we're going to do +2 times row 2 and add that to row 1. So again, row 2 will stay the same. We're really done with that one. We've got all zeros and 1s. Now row 1, I'm going to do 2 times 0 plus 1 is 1. So again, it keeps my lead 1s if we do it in this order. 2 times 1 is 2, minus 2 is 0. And don't forget to do the last one too. 2 times -2 is -4, plus 7 is 3. So now I can say from here, this is like saying, put this in a different color, 1x plus 0y, 0x plus 1y equals 3. So if x plus 0y equals 3 and 0x plus 1y equals -2, our zeros cancel, we know x equals 3 and y equals -2 for our solution of 3, -2 for our answer. And yes, sometimes it is just easier to use your equations, but sometimes it's easier to use this process as we get a lot more variables involved. So we're going to practice it on smaller ones so that we can apply it to even larger matrices here. So again, just to reiterate here, because they are going to get bigger as we continue on. So you really need to make sure you know this process and how to use it. So first thing is write it as an augmented matrix like we did here. Take out all the variables. And then you want to make sure you get your lead 1 first. So you're working column by column. So first column 1, get your lead 1 and then get zeros below it. Then go to column 2, get your next lead 1. So that staircase of 1s, and then get zeros above and below that. In this case, you only needed to get it above. And once you do that, whatever's left in the end, so 1, 0, 3, that tells us x equals 3 and y equals -2. So that's kind of cool at the end. And this stuff is used a lot for coding and all sorts of stuff like that. So it's pretty cool. All right, but a lot of work and very easy to make mistakes on. But I hope you enjoyed doing those. I like those a lot. So that is it for today. I hope you guys are having a great day and continue to. I'll see you soon, and pie out.